A customer opens their banking app and sees something terrifying. They were charged twice for order 42. The engineers investigate, and the strange part is this: nobody wrote a bug. Every service behaved exactly the way it was supposed to. So where did the second charge come from? This is one of the deepest problems in distributed systems, and to understand why Kafka has features like idempotent producers and transactions, you first have to understand the problem they are fighting. Start with the producer. The checkout service sends an event to Kafka saying, charge order 42. Then it waits for confirmation from the broker. Simple enough. But networks are unreliable. Messages get delayed. Packets disappear. Connections reset halfway through requests. So imagine this timeline. The producer sends the event, Kafka receives it and safely writes it to the log. Then Kafka sends the acknowledgement back saying, got it. But the acknowledgement never arrives. Maybe a router dropped the packet. Maybe the connection timed out. Maybe the producer crashed for a second. The reason does not matter. What matters is the producer now faces uncertainty. Did Kafka receive the event or not? And here is the critical point. The producer cannot know. So it does the safest possible thing. It retries. Now, Kafka receives the same event again, and suddenly, order 42 exists twice in the log. Nobody failed. Nobody made a mistake. The retry was correct. Kafka writing the event was correct. The network dropping the acknowledgement was normal distributed system behavior. This creates the 3 delivery guarantees every distributed system has to choose between. At most once means never retry. You avoid duplicates, but events can disappear forever. At least once means retry until confirmed. You avoid data loss, but duplicates can happen. And exactly once means each event is processed one single time. Most real systems choose at least once, because losing a payment is usually worse than accidentally retrying one. Which means duplicates are not an accident. They are a promise. Now, the consumer side has the exact same problem. Consumers track progress using offsets, basically bookmarks showing where they left off in the log. Suppose the payment service reads order 42, charges the customer's card, and then plans to commit its new offset. But right after charging the card, the service crashes before updating the bookmark. When it restarts, Kafka looks at the old offset and says, you never finished order 42. So Kafka sends it again. Second charge. Now, flip the order. Suppose the service commits the offset first, then crashes before charging the card. This time, Kafka thinks the work is complete, so it never re-delivers the event. Now, the payment is lost entirely. That is the trade-off at the heart of distributed systems. Commit late, and you may repeat work. Commit early, and you may lose work. There's no magical ordering that avoids both problems automatically. So how does Kafka fight back? First, idempotent producers. Kafka assigns each producer a unique ID, and every message carries a sequence number. If the producer retries the same event because an acknowledgement was lost, the broker recognizes the duplicate sequence number and silently drops it. The retry still happens, it just stops creating duplicate records. Second, transactions. Kafka can group processing and offset commits into one atomic operation. Either the consumer processes the event and advances the offset together, or neither happens. Inside Kafka, this gives you real exactly once processing semantics. But here's the important boundary. Kafka only controls Kafka. The moment your consumer talks to the outside world, like a payment API, Kafka loses control. Kafka cannot uncharge a credit card. So real systems add one final layer, idempotency. The payment request includes an idempotency key, usually something stable like the order ID. If the same request arrives twice, the bank recognizes it and processes it only once. The duplicate still exists, the retry still happens, but the second request becomes harmless. And that's the real lesson. Reliable systems retry because networks are uncertain. Retries naturally create duplicates. Exactly once is not a default setting. It's something you build using coordination, transactions, and idempotency. The customer sees one charge, and the engineers finally sleep at night.